Do you find that your Kubernetes apps sometimes have outages or performance drops when you run that drain command so that you can upgrade or replace a node? Well, stick around and we'll talk about pod disruption budgets. And later in this video, we're going to look at how to set one up to make sure that our app can continue serving traffic all of the time. To get started with this though, you're going to need an app. Well, obviously. And you're also going to need a Kubernetes cluster. Well, yeah. And finally, you're going to need the ability to actually set up a pod disruption budget. By that, I mean you need the permissions. Run this command and you'll see whether you have the permission. You'll get a response something like this. And once you've got all that, you're set up and ready to go, and we can move on to the next step. But first, you might be wondering, what happens if I don't do this? Can I not just skip it? And how does it actually benefit me and my app? Well, let's take a look at this website over here. It's a deployment, it's got 6 replicas, and it has a readiness probe with an initial delay seconds of 10. Now, the reason I've done this is to simulate a bit of a startup delay. So let's say that it takes some time for our pod to start up. We've got a website, it does some checks against the database, it sets up a bit of a cache, and then eventually reports as ready. That health check is simulating that. This scenario is pretty common. You know, websites don't just instantly come up. You want to have a little bit of a check in there. You might want to delay seconds because you know some stuff happens in the background first, and then you want to start doing your checks. Or you might just have checks that start straight away, but they take a bit of time to respond as good to go. Once this is up and running, it eventually spits out this amazing website. And as you can see, it's got a pod name and a node name, and it just tells us which pod's responding from which particular node. That's it. It's nothing fancy. Let's get rid of that. I mean, it's a design paradise, as you can tell, but it is what it is. Now, I'm going to set a curl command going against that site so we don't have to keep refreshing the website. So I'm going to run that over here in the top right of my terminal. So we'll get that going and we'll just see that same response coming back. At the bottom down here, I've got the pods being displayed out. We can see we've got 2 on worker 0, 2 on worker 1, and 2 on worker 2. And then finally, I've got a drain command over here ready to go. Now, when I drain this node, or one of the nodes, which is going to be worker 2 in this instance, what will happen is it will just kick all the pods off that node that don't have a pod disruption budget. What that means is all pods just get terminated instantly. And we'll see that now. If I do that, we'll see straight away 2 of them go into termination. There you go, both of them there, terminating straight away, and that's it. They terminated before the next 2 were ready and running. So that's not good. These aren't ready, look, you can see they're not ready, they're not responding yet. They're at 0 of 1. You've probably seen this. You've drained a node where your readiness probe and liveness probes are in place, as well as rolling update strategies, and you're getting a reduction in performance. This is why. Rolling updates maintain you have, for example, at least 50%. Over here, I have it so that we have rolling updates max unavailable 2. So in that scenario, if I'm just doing a rolling update to the app, I will always have 4 available. That doesn't fix it when I'm doing a node update though. And that is where pod disruption budgets come into play and will save you in this scenario. Now, a pod disruption budget basically says that you want a minimum of X pods running at any one time. It protects your app against a reduction in performance. And it also means that, you know, like then when we drained the node, they don't just get instantly terminated, the traffic halted, and waiting until a new one comes online. So in that scenario, I drained the node, I had 6 pods, I went down to 4. That might not be the best scenario for you. So let's create one for our app. Now, I've already brought the node back in. I've got ready to restart my curl command. I've got a command ready for my get pod disruption budgets. And I've also got my app redeployed. So it's split across nodes evenly. Again, you can see worker 1, worker 2, and worker 0. We have an even spread again. So let's go over to the IDE now and take a look at how we create a pod disruption budget. So over here, we've got the boilerplate for it. It's pretty standard stuff now. If you've watched all my previous videos, then you'll know what we're doing here. If you haven't, go back, give them a watch, give them a like, give them a subscribe. Why not? You know, go nuts. In here, we have an API version with a policy of V1. We have a kind of pod disruption budget. We have the metadata, which has a name and a namespace of learning. It's pretty standard stuff now across the board. But then we have our spec. The first thing to note is that a pod disruption budget identifies the pod it is responsible for, that it's basically keeping an eye on for, that it's managing. It's done via label selectors. We've seen label selectors before. We use them in deployments. We use them in service. This is a label selector. It targets these labels, which uses label selectors in deployments. That's what's happening here. So we're going to do the same thing. We could pretty much just copy and paste this across here. That's it. So we have a selector. We have match labels, and we're matching the label of app web test because that is the labels of our pod. Now, the next thing we need to do is set a min or max, unavailable or available, depending on what you look at. I personally like to use max unavailable, and this is because I know how many will go unavailable at any one time. By using max available, I might still see a massive reduction in performance that I don't want to see. Let me just lay out a scenario for you. On a normal day, I run 6 pods. I know I can take a hit of 1 pod. So I set a maximum unavailable of 1. Now, if I do a drain on that node and there's 2 pods on it, 1 pod will get removed. And then until that new pod that gets put in to replace it is fully up and ready, the next pod will not get evicted. If I go down the route of minimum available though, I might say I want a minimum available of 3. Now, let's say there's 3 pods on that node. Well, when that node gets drained, all 3 pods will just get drained. They'd just get evicted all at once because I've said I want a minimum of 3. Now, let's say I'm on a busy day where my pods have scaled up to 20 and my pod disruption budget still says I need a minimum of 3. That's a problem because there's a reason my pods have scaled to 20. I'm on a busy day. I've got a scenario where I've got a lot more traffic coming in. I need a lot more resource to handle that traffic. That's why I'm up at 20. If I say my minimum's 3 and I've got 8 pods on one particular node and that node gets drained, all 8 of those pods are just going to get drained out. That's a major issue because I've just lost 8 of the pods that are running my busy day website. That's why I prefer maximum unavailable over minimum available. If I go down the scenario of using max unavailable with those 20 pods, then a drain of the node means that I'll only have a drop to 19 pods at any one time, not drop down to 3. So that is why you need this anyway, and how it's going to benefit you, you'll see any second. So since my pod has a readiness probe of 10 seconds, it will be there for at least 10 seconds before the second one starts the eviction process. It has basically, it'll get evicted, a new one will come in, and it will take 10 seconds before the next one gets evicted. That's the plan here. So I'm going to go ahead and apply this. We'll just go ahead and run that in. We'll jump over to the terminal and take a look to make sure that it's actually picked up the pods it's supposed to be managing. So if I run this, we can see here, we've got min unavailable of not applicable because we didn't set that. And you can only set minimum available or max unavailable. You can't set both because they conflict. But we have a max unavailable there of 1 and an allowed disruption of 1, which means that only 1 pod will drop out when I run a drain. That's the idea behind it. Let's see if it works. Let's go ahead and drain it. We're going to run that curl command. We'll just make sure that nothing drops out. We'll also see here that the container will drop. We'll see an error in the drain command saying that we can't terminate the other one because it will violate the pod disruption budget. And then once the replacement pod has come in line, we'll see the second one drop. So let's just see if this actually works. We're going to run the drain command straight away down here. We will see 1 has dropped out. We've got 1 here running at 0 of 1. We can see up here, we've got an error evicting the particular pod DTQ8B because it will violate the pod disruption budget. And we can see that that one is still responding. Up here somewhere, we'll see that pop up. There you go, DTQ8B. And that one's now ready. We'll see another one get terminated and another one come in. There we go, terminating and creating's come up. Now we've got another one here that's 0 of 1 because we only had 2 pods on that node. 1 got drained, new one came in. When that was ready, the next one got drained. That's how it worked. And you can see here, it all got evicted out correctly, exactly as we wanted it to. The worker node got drained. And that's it. We never saw an outage. We would have seen a slight performance drop if this was a heavily hit website that was doing a lot of stuff. That works exactly as we wanted it to. That's great. So now you've got an app that can maintain its 99.59% uptime and can tolerate planned maintenance, planned node drains. Its performance won't drop significantly because you're not going to lose multiple pods all at once. And you can be confident when doing a managed node upgrade or replacement that you are not going to see a hit. This won't protect you against a node just dying a death because those things happen. They cause major outages when they do, and these things just happen. It's how you manage them that matters, cluster autoscalers and things like that. Now, you probably want to expand on your Kubernetes knowledge a little bit further because pod disruption budget on its own, it's pretty useless. It does nothing. So maybe give us a like, give us a subscribe, then go check out that playlist just there. Or this video just here. Either one of them will be fine.